One thing the book discusses in one of the other first, I think the first question, second question, I think it discusses this about breadth first search when you actually can do it from both ends. So the thing is that how many of you know what knight's tour is? Knight's tour is how many pieces in a chess? How many squares in a chessboard? 64, right? It's 8 by 8, 64 chessboard. Knight travels in essentially it goes 2 in one direction, 1 in the other direction. So essentially it has 8 different locations a knight can actually land from wherever it is. Okay. So one of the interesting things is that there is a way by which you can take the knight to start from one square, and then you can make 64 jumps in such a way that the knight covers every square of the board and then comes back to the point it started, and that is called a knight's tour. Okay, the knight's tour is essentially the knight goes back, so it doesn't repeat any square that it's been on, and it can go around the entire entire chessboard and then come back. That's a knight's tour. It's a very standard backtracking DFS solution. The depth of this tree is fixed at 64, and you have to find a solution which is 64. So DFS just works fine, right? Any questions? Anyone? So at this point, given the problems that we've been dealing with, people should visualize the answer based on just this much information. Okay. The hypothesis is that if you envision a starting point from where you're actually looking at all the items, then from there you're looking at all the items, right? That's what I'm trying to do. So, but if your goal is essentially to find the path to get to here, right? The way it does is that you keep increasing the size of this circle as you go over and over again till you find till you encompass this point. So that is what the point is in a breadth first search. In a depth first search scenario, you could potentially go all the way here, then come back, then go all the way here and come back, and so on, right? So now what we're saying is that instead of doing this as a single threaded depth first search, you could do a breadth first search. You could do a two threaded breadth first search where you start from here, at the same time you also start from here.
It is a star, nothing but.
So again?
A star, I guess.
Not A star. A star is weighted. It just tries to gravitate towards the destination. That's all.
No, but that also starts from both, right?
No. A star is very similar to your. All you're doing is you're just weighting. You prefer the branches that are actually towards the answer. That's all.
Okay. I thought it is same, but it's.
In any case.
Okay.
There's a different algorithm, maybe with the name. I don't know the name for this one.
Okay.
So the theory is that if you do this, right? So essentially, whenever both the solutions intersect is where your answer is. So this would intersect at n by 2. This would intersect at n by 2. If you had done the proper breadth first search, essentially you are looking at n square, it's pi r square, right? Yeah. So you're looking at an pi n square solution, but here you're looking at 2 pi n by 2 square, which is actually better than twice of n by 2 square is actually better than n square.
This is exactly what it is used in a social networking to find the connection. There it is exactly same problem rather than going
what is the degrees of separation?
Yeah, degree of separation, exactly.
So instead of actually trying to figure out are you in my 6th degree, right? That's what you want to find out. Instead of doing that, what you're trying to do is you're trying to find out all your second degrees is their intersection.
Yeah.
And that's a much faster way of actually figuring out. Instead of actually trying to figure out if you are a part of my third connection. Like LinkedIn has first connection, second connection, third connection, right? So, instead of actually, my third connection is like 1 million people. So instead of actually trying to go there, what you're trying to do is you're trying to see if my first or second connection is your first connection. That's much easier. Right?
Okay, explaining this as a bidirectional breadth first search.
Bidirectional breadth first search. That's what the book actually recommends that. It talks about it. There's a code for it. I have not seen any meaningful implementation of this in my career, but I can see applications in social network.
Yes,
I have not done it myself, so that's all I'm saying. I have not used it, so I'm not comfortable with it yet, but that's the theory. Okay?